Either you get this joke or you don't. That's right. Today we're talking about functional groups. Hit the theme.
Ain't nothing but a chem thing, baby. Two flipped out teachers going crazy. Lancaster is a district that pays me. Unbreakable, so please don't try to break this. But back to the lecture at hand.
Hello and welcome to another episode of SchuFu Chemin at Ya. I'm your host Shu, and with me as always is Fu.
What up, nerds?
So Fu, so far we've talked a lot about hydrocarbons, and they're just hydrogen and carbon.
Yeah, they're pretty plain. But now we're going to take some of those same hydrocarbons and we're going to add some funky stuff. So let's get started. Functional groups, a lesson from the organic chemistry unit. Groups that replace hydrogen atoms in hydrocarbons, thus changing the physical and chemical properties of the molecule, are called functional groups. There are many different functional groups, all found on a pirate's favorite table, R. All right, now table R takes up an entire page. It's a really big table, but there's a lot of very useful information on it. So to break it down, the far left column says the class of compounds, so you know which one you're dealing with, whether it be halides or alcohols or ethers. The next column is the actual functional group that's indicative of that class of compounds. So for instance, halides have a halogen like FCl or Br or I. The general formula will always have an R attached to that functional group, and the R just represents a hydrocarbon chain. An example that includes both a condensed structural formula and a name, so it can help you going both ways, either into the structural formula or into the name. Halides, also known as halocarbons. Hydrogen replaced by a halogen, fluorine, chlorine, bromine, or iodine. Used as organic solvents, pesticides, Teflon, and PVC piping. Named using prefixes fluoro, chloro, bromo, or iodo, and numbers. All right, ladies and gentlemen, we have a couple examples here for you. Shu, are you ready?
I think I'm ready. I think my hair looks good, so yeah, I'm ready.
Silent and profiling. All right, so for the first one, A here, we've got a structural diagram all drawn out for us. All we got to do is name it. First things first, let's find our longest carbon chain.
All right, so it looks like I've got 3 carbons in a row, so that is propane.
Very good. Now, what is that thing that is out of the ordinary? Here, we're going to circle it. This is our funky stuff. And by funky, I mean it's different than just a hydrocarbon alkane.
Yeah, it looks like we've got a fluorine in there.
Okay, so now we have some funky stuff, so we need a functional group.
So that's a halide, and it gets a special prefix, right?
It does.
Fluorine is fluoro.
All right, and just like real estate, location, location, location.
All right, it's on the second carbon. So I want to specify that it's on the second carbon, so 2-fluoropropane.
Very good. All right, taking a look at letter B here, we got 2,2,3 trichlorobutane. Again, this looks long, but let's break it down into the long chain first.
All right, so it looks like I've got butane, so I'm gonna draw 4 carbons in a row. Then I've got trichloro, so that must mean again I have a halide. This time I'm putting chlorines into my main chain, right? So
Yep.
There's 3 of them, and it looks like they're on carbons 2, 2, and 3. So on carbon 2, I guess I've got to put a chlorine and another chlorine, and then also on carbon 3, a 3rd chlorine.
Very good.
All right, so I'll add in my lines for hydrogen. Do I have to do the same thing for chlorine, add the extra lines?
You do not. Only the one bond for your halogens is good enough.
All right, so it's only the carbons that get bonded to hydrogen.
Correct.
Alcohols. Hydrogen is replaced by a hydroxyl group, OH. Now technically this is not a hydroxide ion, OH-. It's called a hydroxyl group, just OH, no charge. Alcohols are non-electrolytes, but they're slightly polar solvents. They're used as a gasoline additive. Named by removing E, then adding OL or all, and numbers. All right, we're gonna do some examples of alcohols. You ready, Fu?
I am.
All right, let's name letter A. We wanna start by naming our main chain.
All right, looks like I got 2 carbons here, so ethane.
All right, good. Let's find our functional group. off of the main chain.
All right, well, that looks like that OH right here. Not an H, it's funky.
All right, good. And what functional group are we talking about?
OH is the hydroxyl group. That means I have an alcohol.
Good. So we're going to drop our E at the end of ethane. And we're going to add the ending OL to show that it's an alcohol.
Ethanol, alcohol. Okay.
Now, most alcohols do need a number to specify which carbon the OH is coming off of. But in this case, it's such a short carbon chain that no matter what I put the OH on, it's always going to end up being carbon 1, so it's sort of redundant, and so we don't put a number here.
Okay.
All right, we are going to draw a structural formula for 2-butanol. Let's start with that main chain again in the name.
Okay, so bute and means it's 4 carbons.
Good. What's the OL mean?
OL means it's an OH group, an alcohol.
And what's the 2 specify?
It tells me location. Numbers tell me location. So on my second carbon, does it matter if I go up or down?
Does not matter, as long as it's on the second carbon.
Okay, I'll draw that one up and just
fill in our lines, our extra hydrogens.
Yeah, all right.
4 carbon.
Let's get those in. And is that it?
Looks good.
All right. Ethers contain O in between carbons in the main chain. Former anesthetic, now used as solvents. Name each side of the O as an alkyl group, then add the word ether. All right, a couple more examples. Shu, are you ready?
I'm ready.
All right, so unlike the previous examples, we don't really have a long chain here, right?
No, it looks like there's an O right in the middle.
Yeah, you got a couple of branches off of that O. So that O is the funky stuff. I see you went ahead and circled it. Very good. So now we have 2 branches. So this is an ether. So we're going to name both branches and then simply say the word ether.
Okay, so over on this side here, I've got 1 carbon. So that's meth for a prefix, right?
Yep.
And since we're naming it as a branch and not a main chain, YL.
Good.
So methyl. And then on the other side, I've got 2 carbons as my branch. So that would be eth with the ending YL. So ethyl, and then just the word ether at the end because of the oxygen.
Just the word ether. Yeah, that's all we got to say at the end is ether.
That's a pretty cool name. Methyl ethyl ether.
Okay, we got another example. We're going to draw the structural diagram of diethyl ether.
All right, so I know it's an ether, so there's going to be an O right in the middle, right?
Good, so for ethers, we'll always start with that functional group, that O.
Okay.
We know we have branches each way. That's what an ether is. So now we just have to figure out how long each of those branches each way are.
All right, so ethyl means 2 carbons in a branch. Diethyl ether must mean there's 2 carbon branches, 1 on each side.
That's right.
All right. 2 on each side. And then I just have to add in my lines for hydrogens. Don't want to do it on oxygen, right?
Nope, oxygen gets 2 bonds. That's already got it.
All right, that should be it. Diethyl ether.
Now in example B, they were both the same length of branch. That's why it was diethyl. So sometimes they're going to have different length branches. So does it matter whether I put the 2 C's on the left or the 3 C's on the right, or does that matter? What I always tell you is you can use ether.
Aldehydes. Hydrogen is replaced by a carbonyl group on the end of the molecule. That's a C double bonded to an O. Include formaldehyde, a preservative, and vanilla and cinnamon flavorings. Name by removing E, then adding Al, but no numbers since it's always on the end of the molecule. All right, we're gonna do some examples of aldehydes. You ready, Fu?
I am.
All right, we're gonna name this first structure, starting first with the main chain.
All right, that's right here.
All right, so how many carbons do we have?
That's 4.
All right, so name the main chain alkane.
Butane.
All right, we are going to find that functional group so we can decide what to do with this next.
It's a double bonded O right there.
Right, and notice how it's on the end of the chain. That's how we know that it's an aldehyde.
Okay.
All right, we're gonna drop the E off of butane.
Okay.
And we're gonna add the ending Al. Now careful how you pronounce that.
Butanal.
Butanal, good. And we don't wanna mix that up with butanol, which would be an alcohol, so really stress that Al at the end. Butanal. Say it, butanal.
Butanal.
Oh yeah, that sounds good. All right, let's move on to ethanal.
Okay.
Ethanal. All right, so we want to break this down. Let's start with our main chain within the name.
All right, so F means 2, so 2 carbons.
Good, and what's the Al at the end of that name tell us?
Al means it's an aldehyde. It's got a double bonded O at the end of the chain.
Good.
So I'm gonna draw a double bonded O right there.
And now let's get all those carbons, 4 bonds.
All right, so that first carbon needs 3 to get 4, and that carbon already has 3, so just 1 more.
Exactly, good. We'll always have 1 hydrogen bonded to that carbon that has the double bond to the O. Good.
Ketones. Hydrogen replaced by a carbonyl group on the interior of the molecule. So it's a C double bonded O, but now it's in the middle as opposed to on the end. They are slightly polar solvents. They include spearmint flavorings. Named by removing the E, then adding ONE, and a number for 5 or more carbons. All right, let's do some ketone examples. Shu, are you ready?
I'm ready.
All right, so we've got a structural diagram here. Let's get the long chain off of it.
All right, so let's see. I've got 1, 2, 3, 4, 5, 6 carbons. So I'm gonna name that hexane.
Very good. Now we have a functional group somewhere here. You mind circling it for me?
All right, so the functional group is the C double bonded to the O.
All right, so what is that a functional group of?
Well, it's on the interior of the chain, not the end, so it's a ketone, not an aldehyde.
Very good. So this is going to end in what 3 letters?
O-N-E.
Good, so we're gonna drop that E and add O-N-E.
All right, so drop the E and add O-N-E, so hexanone.
Very good. Now, we should bring up at this point that we're not going to drop the A-N, and a lot of students make that mistake. The A-N, that still tells us something. That tells us that this has all single bonds, so every part of the name tells us something.
Hexanone, not like hexone or something like
Yeah,
that.
students commonly drop that A-N, and don't do that. Drop only the E. All right, so now we have to worry about location, location, location. So where is that functional group?
Looks like it's on carbon number 2, and that does keep it on the lowest carbon number. I wouldn't want to number the other way.
Very good.
All right, so specifying that it's on the second carbon, 2-hexanone.
Very good. All right, now we have a name. We're going to go into the structural formula. So we have propanone.
All right, so I see propane in there. Prop is 3,
Very good.
and the O-N-E at the end tells me it's a ketone, but there's no number. So where do I put the C double bonded to the O?
Well, in this case, you don't need a number because the chain is so short. There's actually only 1 interior carbon.
Oh, interior carbon. So it's got to be on this middle carbon.
Good, because if it was at the end, what would it be?
It would be an aldehyde. That's a different functional group.
Good, so interior carbon, ketone, on the end, it's an aldehyde.
All right, good. So I'm just going to add in my extra hydrogens, and the carbon in the middle already has 4 bonds around it, so looks like I'm good.
Very good.
Organic acids. Hydrogen replaced by a carboxyl group on the end of the molecule, COOH. Cool. These are weak acids like citric acid or vinegar. They're named by removing E, adding oic acid, but no numbers since it's always on the end of the molecule. All right, let's do some examples of organic acids. You ready, Fu?
I am.
All right, let's start with that main chain.
All right, looks like we've got 4 right there down the middle.
All right, so what are we gonna name that as an alkane?
It looks like butane.
All right, let's find our functional group, our funky stuff.
Looks like all of this, that's COOH.
Yeah, notice we have a C double bonded to an O and then an OH attached to that same carbon. All right, so we've got an organic acid here. We want to drop the E.
Okay.
We're going to add the ending oic acid. So butanoic acid, don't need a number. It's always on the end of the chain.
Okay.
I want you to circle that hydrogen on the very end of the functional group.
This one?
Yeah, and draw an arrow, and then write H+.
Okay.
These are acids, remember. Remember that acids will ionize in solution. Most organic compounds do not actually ionize in solution, let alone even dissolve in water. but this will remove an H plus from its structure in water, and that's what makes it an acid.
Okay.
All right, let's do our drawing for methanoic acid. Let's find that alkane in the name.
Okay, meth is just one carbon.
All right, so we've got our oic acid. What's that have to mean?
That means it's got that COOH.
Good.
But I already got a C. Do I got to add another C?
Nope, that C is included within the functional
Okay,
group.
so just the OOH then.
Exactly.
OOH.
Just
Okay.
need one more line though to give carbon 4.
Oh, I see it. Yep, so carbon has to have 4. It's got 3, so 1 more.
So there is a hydrogen on the end there. Very good.
Esters contain COO in between carbon atoms in the main chain.
I have an Aunt Ester.
Is she smelly?
Kinda.
Well, esters are smelly
Oh.
because they're found as aromas and flavors such as banana and wintergreen oils. Name the carbon chain containing the carbonyl group. C double bonded to O, drop the E, and add OATE. Then name the carbons attached to the O as a branch, an alkyl group, and use as a prefix. All right, ladies and gentlemen, a couple examples here of esters. Shu, are you ready?
I'm ready.
All right, so esters and ethers are a little bit different. We're going to circle our functional group first, as opposed to finding that long chain.
Okay, so I got the C double bond OO kind of in the middle of the chain, so that shows that I have an ester.
All right, what I would like you to do then is with the C that you circle, I'd like you to box that and any other C's that might be attached to it.
Well, it looks like it's just one for this one.
Okay, so the part that's attached to that functional group, that's the chain. That's the part we're going to name with the proper ending, all right? So how long is that?
Just one carbon.
So what's the prefix for one carbon?
Meth.
Okay, so it'd be methane normally, right?
Okay, so methane. Got it.
We're gonna drop the E
We're gonna drop the E
and add OATE.
and add O-A-T-E. Methanoate.
Very good. We have one final part that we haven't even circled yet in our structure. Go ahead and circle that.
Okay, so this is what's left attached to the O.
Yeah, remember we box our chain, but we're going to circle off any functional groups. Now this should look familiar. We've seen quite a few of these. This is an alkyl group. How long is this branch?
Just 2 carbons.
All right, so 2 carbons is what prefix?
Eth.
And it gets a what ending for branch?
YL because it's a branch. So ethyl. And then I'm going to circle that too. It goes with sort of the branch off of the oxygen.
Very good.
Ethyl methanoate.
Very good. All right, now we're going to take a name of an ester and go back into the structural formula.
This is sort of like the opposite of the other one. It's methyl ethanoate. This is confusing.
Every part of an organic name has a meaning. So if we just break it down, we can figure out how to draw this. So, yeah.
I'm going to start with the ethane part, right?
Good. We're always going to kind of go in reverse here. Start from the far right and work your way back. So we've got 2 carbons in a chain.
Okay. And then it says O8 at the end, so I know that it's going to be an ester, right?
Good. So it has that functional group of the double bonded O and the single O, both attached to the carbon.
So does it matter where I put the C double bonded to the O?
It technically doesn't, but you got to be careful then as to where you end up putting that branch on. So you can pick either.
All right, I'm going to pick the first one. So I got the C double bonded to an O, but there's also an O attached to the carbon, so I'd have to go this way.
Good.
Right?
So the last thing to do then is the methyl branch part here, which will always be the other side of the O in an ester.
All right, so methyl means 1 carbon, and it has to be on the side that's just attached to the oxygen.
Yeah, so that
right?
single bonded O, oxygen needs 2 bonds. It only had 1 with the functional group, so give it that 1 more, and then attach your alkyl group.
Okay, so you know what? Again, because this gets so confusing, let's do the boxes thing. So the ethanoate is over here, and then the methyl is over here. So it's not really about left or right. It's just about where it is with relation to the functional group. So it's like the ethanoate is the main chain. It always has the C double bonded to the O. And then the methyl part is a branch. It always comes off of the oxygen.
Good, yes. This is one of the most difficult ones to draw in organic chemistry. You did a good job.
All right, I just have to add my hydrogens. I don't want to forget those.
Almost forgot.
And it looks like this one and the C double bond O doesn't need any hydrogen. Oh wait, I missed that one. And we're good to go. Amine. Hydrogen replaced by nitrogen. Nitrogen gets 3 bonds, so it's usually a dash connecting to the carbon chain and then NH2. Found in vitamins and hormones.
Wow, it's found in vitamins? I mean, that's pretty cool.
It is. Named by removing E, then adding amine and number. All right, let's do some examples of amines. You ready, Fu?
I mean, I am.
I see what you did there. All right, so we're back to looking at the main chain for amines.
All right, so I got 3 carbons right here down the middle.
All right, so how do we name that if it was an alkane chain?
Propane.
All right, so what's our functional group here?
Looks like it's right there.
Right, we're gonna normally see it as NH2 coming off of the carbon chain. All right, so to name, we wanna drop the E off of propane.
Okay.
And we're gonna add the ending amine.
A-M-I-N-E.
And be careful, just like we talked about with ketones, propamine sounds like a legitimate chemical name, and it's not. We gotta keep propane, that's the alkane, drop the E, add amine, so it's propanamine, not propamine.
Okay.
The last thing we need is a number to specify which carbon number the amine group is coming off of.
Gotcha. So it looks like it's on my middle carbon or my second carbon, so 2 propanamine.
Looks good. All right, let's draw a structural formula for 1-butanamine. Let's start with that main chain again.
I'm starting to get this. I see the functional group there along with the long chain butane. So butane, 1, 2, 3, 4 carbons for bute.
Good, and where would that amine group be?
It says number 1 here, so it's on the first carbon or the last. Can I do either?
You could do either. What are you in the mood for?
I'm gonna go crazy. I'm going to the right. So,
good. So that's still gonna be numbered carbon 1. So we're allowed to put it on the end.
Put a nitrogen there.
All right, let's fill in our extra bonds. Remember, carbon gets 4 lines around it for 4 bonds. Nitrogen only needs 3. It technically has that unbonded pair, which we don't normally show in structural formulas.
Because there'd be 2 H's at the end, 2 at the end there.
Very good.
Okay. Amides contain a carbonyl group, C double bonded O, and an amine group, the NH2 group. Peptide links in proteins, named by removing the E, then adding amide, but no number. All right, ladies and gentlemen, I have a couple examples of amides for you. Shu, are you ready?
I'm ready.
All right, let's find that longest chain.
Okay, so looks like I've got 2 carbons there.
All right, good. What's the prefix for 2 carbons?
That would be eth, so ethane.
Good.
All right.
And we're gonna circle our functional group here. Be careful, because amides have quite the functional group.
Yeah, it's all of this actually.
Yeah, I got a carbonyl group and an amine group, but the key is that they're both attached to the same carbon. So now instead of both of those, we have an amide.
Okay.
All right, so we have to drop the ending E.
All right.
And add amide.
Okay. So ethanamide. Ethanamide. Do I need a number?
We don't, because this will always end up being at the end of your chain.
Okay, sounds good.
All right, we gotta have another one of a name. We're gonna get into a structural formula. So we have pentanamide.
All right.
So what's our longest chain?
Our longest chain would be 5 because of pentane. So 1, 2, 3, 4, 5.
All right, and our functional group is amide. So this is always occurring at the end for amide. So what does our functional group look like? You can use table R if you need to.
All right, so I know I have a C double bonded to an O. And connected to that, I also have a nitrogen, which I know is going to be NH2. I'm going to put the lines in right away.
Missing one last thing. We have to go through and give hydrogens to all of our carbons that need 4 bonds.
All right. Looks like that N carbon is good.
Yeah, be careful. That double bonded O to a carbon, that's the one that students like to draw an extra bond on, which ends up making it 5, so just be careful.
All right.
Very good.
Amino acids. Amino acids contain a carboxyl group, COOH, and an amine group, NH2. Unfortunately, it's not on table R. You're just gonna have to recognize that you have an organic acid, that's the carboxyl group, And an amine, that's the NH2. So get where the name comes from, amino acid. These are essential to building proteins. And you don't have to name them, just recognize them. You try. For each of the following, identify the functional group present. Note that A through C are on this slide and D through F are on the following slide. Well, that's gonna do it for today's episode on functional groups.
Later, nerds.
Promotional consideration by
Anger disc. Throw your anger away.
Step 1.
Write why you're mad on the disc.
Step 2.
Hurl it into the ocean.
But we never off, always on to the break of dawn. SCIENCE in the hall they call S-Wing. You know we never wear a tie like my homies, boys to men. It's so hard to say goodbye.
Like this, that, and this, and it's like that, and like this, and like that, and it's like this.
You're going in low power mode.
Plug and chill to the next episode.